Let's take a look at the 1-point perspective cube. That one is actually quite easy. With 1 point, as it says, we only deal with 1 point, our midpoint. So how do we draw actually a 1-point perspective cube? Let's say we draw a line. We draw a line. Ideally what you want is that your left and your right are exactly equally apart from the midline. And then to the midpoint we draw a line. Number 1 and number 2. Okay, so can, for example, draw a vertical line up there and there. And because in 1-point perspective we can actually measure also the horizontal and the vertical line, by the way, to gain actually a perfect proportional rectangle. And there. Okay. So few lines are missing. For example, a line there and a line there. And at least now we have actually our front square. So I will ink this a little bit stronger so you can see it there and there. So, but how do we actually deal with the foreshortening of the back part? So how do we actually figure this out? So there's a little trick we can do. From the vanishing point left through the lower corner here, I draw a line till it hits this midline. Kind of there. Then from the right vanishing point, again through this point, no, on the right side, I draw a line. And you see that where these two cut should be right under the midpoint. Okay, so we're actually pretty close. What I need now is actually from there a line going to the vanishing point, and I have everything I need, but I just continue and put in the other line there, and you see again these two cut somewhere there. So you might realize that actually what I just sketched in is a 45-45 proportional square. So we can use actually the square 45-45 2-point as a tool to measure the depth of a 1-point perspective cube. And you see where this line touches the left and we go over, touch the other one touches the right. There we have actually our back face. Now this is a proportional cube in 1-point perspective. And this measurement trick only really works in a 45-45. The 1-point perspective cube obviously is not really the most beautiful or useful one. It has only limited use, but in certain situations it is actually a quite useful construction method, specifically when, let's say, we look into a room, or if we would like to draw our product really directly from the front. So you see I can make use of a 45-45 2-point perspective square to establish the distance of my cube, and then I can mix this together with 1-point perspective to construct actually a cube where the front face is really facing me and is not rotated. To draw now a room, we have to measure the space and also get some standard dimensions. So when we draw a room, we deal with the ground, we deal with the eye level, and we deal with the ceiling. Let's assume we're here in the US. The standard height of the ceiling is 8 feet. Kind of like an average body height is 5 feet 10 inches. To make this a little bit easier right now, we simply say 6 feet. And the horizon line is actually where our eyes are. So from the bottom, 6 feet up, that's actually then where our eye is, and another 2, that's where our ceiling is. To do something like this without having, for example, a measurement tool, you see I just created myself some lines. So 0, 1, 2, 3, 4, 5, 6 feet, 7 and 8, and the same here. So I can now, for example, draw a line and draw a line, roughly draw a line, and plus minus draw a line here. That's one very crude and quick way, just by working with line elements. So you're kind of like in a proportion. However, because we're in 1-point perspective, again, the vertical line and the horizontal line can also be measured. Obviously up in the front, nothing actually to the back. And we can, let's say when this should be 8 inches, draw actually a line 8 inches and 8 inches. Now we basically set then 1 inch equal 1 foot, or maybe 8 centimeters equal 1 meter, based on how you would like to work. And then we can draw, for example, a line to the midpoint there and there. So now we have the left and the right ground corner. Can do the same with the top. This is actually the right and the left ceiling corner, but we don't really know right now where, for example, our back edge is. And because this is, and this only again works in a 45-45, not 45-45, this only works actually in a 1-point perspective cube, where the cube is perfectly centered in front of the midpoint, because then we can use this to create below it a 45-45 cube. So you see here, from this edge I draw a line over kind of like to there, and then can do the same, the opposite. And to measure everything, if I draw a straight line down, should be close, there's a little bit of inaccuracy, and these two should touch. So there's basically now my proportional space. So here I can draw a line up, and I can draw a line there, and I can draw a line there. So now I have a room that is 8 feet or 8 units wide, 8 units tall, and 8 units deep. And it is drawn from the eye level of an average, let's say, 6 feet person. So you see, when everything gets lower, then actually it will look like, for example, we are under the ceiling. So let's say we create something that looks like this. So here, let's draw these lines quickly in a little bit so you understand how I mean this there now. So you can clearly see it looks like the eye is actually under the ceiling, like Spider-Man. And if we do it the opposite way, let's say here we create something maybe this way. There you can see this feels like you're lying on the ground. So that's the reason why it's so important to really be mindful of where's the top edge, where's the bottom edge, no? Ceiling and floor, and in relationship in between, where is the horizontal line, because that defines then the eye level. So to create maybe a room that instead of 8 units is, let's say, 18 units deep, let's see what we can do. So what's the easiest way to do the foreshortening? In this case here, from this corner, I draw a line over till it touches this part there. That actually works. And if I go to there, I have the next one. And if we draw a line up and there and down, now we have a room that is 8 by 8 by 3 times 8. So 24. We see that actually the foreshortening of a 1-point perspective cube is quite easy. All we need to do is basically shoot a line to the vanishing point, and then where it cuts one of these lines, or to the right vanishing point where it cuts it there, we just put in horizontal lines, and then this way we can foreshorten it. One of the big downsides of the 1-point perspective cube is we can't really see actually the left and the right. 1-point perspective cube is good to look into a room, and when showing an object, it kind of like only offers limited usability. So let me quickly here recreate a small box. So let's say we have a box this way and there and there and here, there in the back, and then we have a line also roughly here. Okay, good. Let's hide all these lines. Okay, so there you see what I mean. We can see the front, we can see the side. Let's say we have an object actually maybe like this. So it's kind of like a cube, and this part we can't really see. This is at an angle. So there is the trick to do kind of like a left and right shift, if you want to call it this way. So what we can do in that case is, let me create a new layer. So I will do it a little bit quicker this way, so you can see what I mean. There. Okay, and then here I draw a line down. So, and then let's actually erase some of these lines. So there you have it. So there you can actually see that I can see the front, the top, and I can see a little bit of the right side. So, and the shift only works to a certain degree. You can't actually move it left and right too much. If you compare this angle to this angle, you see that this is pretty aggressive already. So in 1-point perspective, you want to have an object that's kind of like there. You don't really want to have an object that is super wide. Otherwise, the further you go to the right and the left, you will see with this one-point perspective construction method, the object seems to bend, and it's just a flaw of the way how we construct a one-point perspective. It's not really that it will be bent, the lines are, for example, all horizontal, but you will see that there is an interesting deformation going on. So we simply can move the object from the center point a little bit to the right, simply to show then more than two sides, but then we should actually leave it at this. We shouldn't really go necessarily more. And also there, oh, okay, let's delete this one. Let's go back to there, here, zack, zack. So what I wanted to show is when we draw a line, and we actually draw a line, also here this technique works out. Zack. And from there to there, there. And if this is correct, these two should be, and they are. So also now here I have actually my front and back vertical edges, and then all I have, since this front vertical I can measure, I just have to draw in these lines, measure it, and there we are. I'm a little bit off here. Oh, something went wrong there. Let's see. Huh, interesting. Oh, I mean, there it matches. Okay. So you see also there we can create kind of like a proportional square in case now the vertical line is not high enough to actually make this a square. But you see, if we do a left and right shift, we can still then utilize this method to measure actually the correct foreshortening to create a proportional square on the ground plane.